Welcome to another session of Ebenezer GATE coaching class. This is a problem that appeared in GATE 2002. It is a multiple choice question for 1 mark. A Zener diode regulator in figure is to be designed to meet the specification IL equal to 10 milliamp, V0 equal to 10 volt, and Vin varies from 30 volt to 50 volt. The Zener diode has a VZ of 10 volt and the knee current of 1 milliamp. For satisfactory operation, what is the value of R? We'll have to find out what is the value of R. Now, we are given the input varies from 30 volts to 50 volts. So, input Vin is varying from 30 to 50 volts. Now we will have to find out what should be the value of R. So that means we have IL fixed at 10 milliamp. So IL is 10 milliamp. So when IL is 10 milliamp, what should be the value of R so that this diode is in the breakdown region? Then only it will work as a regulator. So the current through the Zener diode is 1 milliamp. This is 1 milliamp. The current, load current is 10 milliamp. So this I2 is going to be 1 milliamp plus 10 milliamps, or I2 is going to be 11 milliamps. Now, to find out what is R, so for the least voltage here also, the Zener should be in breakdown voltage. So, and Zener breakdown is 10 volt. VZ is given as 10. So the drop across resistance VR will vary from, if it is, if will be Vin minus 10, or Vin is varying from 20 to 30 to 50. So it is 30 minus 10 is 20 to 50 minus 10 is 240 volts. Now for 20 volts also, this Zener should be in breakdown, and for 40 volts also the Zener should be in breakdown. Now the current through the resistance is 11 milliamps. So if you assume that VR is 40 volts, then the resistance will be 40 divided by 11 milliamp. Let us assume VR, well, let us assume the highest value VR as 40 volts. Then R will be actually 40 divided by 11 milliamps, which is going to be nearly 3600 ohm. Now, if you assume R as 3600 ohm, then when VR is 20, for VR 40 we are getting 3600 ohms. When VR is 20, then the current will be very less and it will not permit the Zener diode to be in breakdown. So this is wrong. I don't assume VR as 40 volts. If I assume VR as 40 volt, I get a higher resistance. I get a resistance of 3600 ohm. But if you put 3600 ohm here, then when input is 30 volt, VR should be actually 20 volt. But for a current of 11 milliamp, VR will not be 20 volt. If IZ plus IL is actually 11 milliamp. And if I put if R is actually 3600 ohm, then it's going to be, VR is going to be 3600 times 11 milliamps, or this is going to be 3.6 into 11. So it is more than, it is going to be nearly 40. Whereas your VR is only 20. So this is not going to work. So always you will have to take the lower value of VR to find out the resistance. So if you take the higher value of VR, you will get the wrong answer, because for the higher value of VR, the resistance is 3600 ohm. But if you put 3600 ohm, for the lower value of the input, it will not work as a regulator. So whenever you do such problems, you should take the lower value of the input and not the higher value of the input. So when you take the lower value of the input, then you will get the correct answer. Let me take the lower value of the input. So when I take the lower value of the input, Vin is now going to be 30 volts. V out or Vz is going to be 10 volts. So VR is going to be V in minus Vz, which is going to be 30 minus 10 equal to 20 volts. So R should be 20 divided by 11 milliamp. 11 milliamp is the minimum value of current. So R, if the current is more than 11 milliamp, then R will be less. So R should be less than 20 by 11 milliamp, or it should be less, which is 1800. So the answer is R should be less than 1800 ohm. Option is A, R less than or equal to 1800 ohm. Thank you. God bless you.